Hi guys, my name is Derek Tan. The advantages of using an AC induction motor is that AC induction motors don't have brushes and usually have a much longer life than a DC motor. Also, the AC motor speed control is achieved by varying the frequency of the alternating current. An AC motor is a motor that converts the alternating current into mechanical power by using an electromagnetic induction. The two most important parts of the motor is the stator and the rotor. The stator is the stationary part and the rotor is the rotating part. AC motors can be two types. One is synchronous, the other is induction. And under induction motor, it can be single-phase induction motor or three-phase induction motor. Both the stator and the rotor produce rotating magnetic fields. And in the windings of the stator, this rotating field is provided inherently by the sinusoidal nature of alternating current. And in the rotor, the magnetic field is created by permanent magnets, reluctance saliency, or by additional electrical windings. Synchronous motor converts the AC electrical power into mechanical power only at the synchronous speed. And when current flows through the synchronous motor, a revolving field is set up. Also note that a synchronous motor is not a self-starting motor because revolving field tries to drag the rotor with it but could not do so because of the rotor inertia, and therefore no starting torque is produced. Induction motor converts the AC electrical power into mechanical power by using an electromagnetic induction phenomenon. When the stator windings are connected to an AC supply, a flux is produced in the air gap, and then the flux rotates at a fixed speed. And this rotating flux induces voltage in the stator and rotor windings. But if the rotor circuit is closed, then current is able to flow through the rotor winding and reacts with it. Therefore, torque is produced. But in a steady state, the rotor rotates at speeds very close to a synchronous speed.
Assalamualaikum and a very good day, sir. My name is Kelvin Ling Zhong Xian. DC motors are highly converted for speed control and output range. It consists of an stator, an armature, a rotor, and commutator with brushes. Opposite polarity between the two magnetic fields inside the motor causes it to turn. It is equipped with magnets, either permanent magnets or electromagnetic windings, produce a magnetic field. When current passes through the armature, also known as the coil or wire that plays between the north and south pole of the magnet, the field generated by the armature interacts with the field from the magnet and applies torque. In a DC motor, the magnet forms the stator. The armature is placed on the rotor and a commutator switches the current flow from one coil to the other. The commutator connects the stationary power source to the armature through the use of brushes or conductive rods. Furthermore, DC motor operate at a fixed speed for a fixed voltage and there is no slip. For DC motors, the energy used comes from batteries or another provided sources of power which provides constant voltage. DC motors gives better variable speed and power and generate more torque than AC motors. To compare with other electrical appliances such as washing machine, its AC motor are powered with alternating current. AC induction motors do not use brushes and they are very rugged and have long life expectancies. Moreover, the speed of the AC motor is controlled by varying the frequency, which is commonly done with an adjustable frequency drive control.